Alright, so today we're going to be talking about Bayes' rule. And Bayes' rule was discovered by some dead old white guy that we probably don't care about, but what he solved was something called the converse problem. Before, with conditional probability, we were doing something where we would have some event and some characteristics, and we would want to find what's the probability of this event happening given that we know these characteristics. Bayes' rule does the opposite of that, the converse. It says, what's the probability that if this event happens, that these characteristics were present or true, right? So it's the opposite. Now, here is the equation for Bayes' rule, and brace yourselves, it's a little bit long. Here it is. Take it in. Even though it's a little bit long, it's not impossible to memorize. And the reason for this is because Bayes' rule is actually made up of two different formulas that you probably already know, conditional probability and the law of total probability. If you don't know those two, you should probably brush up on them because it's kind of impossible to do Bayes' rule if you don't know these two. Let's set them down up there and let's try to solve out Bayes' rule. So what we're trying to find here is the probability of B1 given that some event E occurred. So let's write that down. That's our starting point. And then already with conditional probability, we can take this and set it equal to this in its respectful variable form. So it would be P of B1 and E all over P of E. Alright. But now, what if we don't know the probability of E, right? We're only given certain probabilities, and let's just say P of E is not given to us. So that's where the law of total probability comes in, right? We can rewrite the entire bottom part as this, because that's what it equals. And that's the cool thing about this. You don't really need to memorize it. You just need to memorize these two equations and then find them. Alright, awesome. We've simplified it some more. Or rather, complicated it. But in that same way, we've simplified it for ourselves because we're going to know some of these probabilities. Alright, there's one more step to do. Let's say that we don't know this probability. We're going to have to replace it with something that we do. So let's use our conditional probability equation again, and let's set the top of this fraction equal to this probability formula rework. So to make this make a little bit more sense, what we can do is we can just rearrange how they show up, right? This is the same probability as this one, but you can see why we're substituting it for what we are more clear. So this is equal to over P of B1, and then we solve backwards, so we see that this first thing should be the first given B1, right? So if we hadn't rearranged this, we might have set this equal to this probability over probability of E equals the probability of B1 given E, and we don't know that, right? So that's why I recommend rearranging these two to make things clearer for you, but also, like, don't set it equal to this, because like I said, you don't know that. So now if we just multiply this across, we get P of E given B1 times P of B1 is equal to P of E and B1, right? And look at that. That fits our numerator. So we can substitute this whole thing into there. Alright, and now we have it set equal to the same thing that the formula is. So you can see how from a sort of simpler version, we were able to complicate it, but also make it easier for ourselves and the word problem that we're given. So now that you know where Bayes' rule comes from, let's do a problem. So in this problem, there are two different weathermen on two different channels. Martha watches Weatherman 1 20% of the time, and Weatherman 2 80% of the time. Weatherman 1 is wrong 10% of the time, while Weatherman 2 is wrong 8% of the time. Suppose Martha expected it to rain, but it is actually sunny. Which weatherman did Martha most likely watch? So in this problem, you're doing Bayes' rule not once, but twice, because you want to find the probability that it is the weatherman, given that they're wrong, for both weathermen. So to fully illustrate my point about how Bayes' rule is the converse of sort of conditional probability, so in this problem, we're trying to find what's the probability that it was weatherman 1 who was wrong, versus what's the probability that it was weatherman 2 and given that they were wrong. So we're trying to compare those two probabilities. Whichever one is bigger is the weatherman that Martha was most likely to watch. Versus conditional probability problems that we might have done in the past, where we were trying to find what's the probability that the weather was predicted wrong, given that it was weatherman 1, right? So you can see sort of the converse relationship. So what I like to do in word problems is I like to pick out the information and set it equal to variables. So here it says she watches weatherman 1 20% of the time. So probability of man 1 is 0.2. Then she watches weatherman 2 80% of the time. So probability of man 2 is 80. And then he's wrong 10% of the time. So when Martha watches weatherman 1, he's wrong 10% of the time. So that we can define as the probability that he is wrong given that it's weatherman 1. 0.12. Then weatherman 2 is wrong 8% of the time. So probability wrong given weatherman 2 is 0.08. Alright, now we've picked out all the information, so now let's solve for what we want. We're trying to solve probability that it was weatherman 1 who was wrong. Oh. Maybe pick better variable names than me. So, we're trying to find probability of wrong given weatherman 1. So we have that right here. 0.10 times the probability of M1 is 0.2. Next, we just take the same numbers, right? Because these two are the same here, to find the total probability of being wrong. And then we want to find the probability of the second weatherman being wrong. So that would be 0.08 times, at what probability does Martha watch the second weatherman? She watches 80% of the time, right? So that is how we find the probability that the weatherman was the one that Martha watched when he got it wrong. So this ends up being 0.238. Cool. Now let's solve for the other one. What's the probability that Martha watched weatherman 2 given that he was wrong? Probability of man 2 given wrong. So now we have to pick out that information. What's the probability that he's wrong given that it's weatherman 2 is 0.08 times what's the probability of Martha watching weatherman 2? 0.8 all over. We just take this same denominator because it's the same numbers. They're not going to change. Solving for the total probability of the event that the weather is determined wrong. This ends up being 0.761. So, we wanted to see which weatherman did Martha most likely watch. So, the weatherman that she most likely watched would be the second one, right? The probability, given that the weather was determined wrong, for it being weatherman number 2 is a lot higher than the probability that it was weatherman 1 that she watched, given that the weather was determined wrong, right? There's about a 0.5 difference. So, that's how easy Bayes' rule is. Ooh, it's the end screen. Click on one of these links to be directed to that playlist. And don't forget to subscribe!